So hopefully you went through and worked this example. If not, what I would suggest is pause the video, go back, rewatch video 2, make sure that you're okay doing that one before going through, and try to work through it. And what I'm going to do is I'm just going to go through and illustrate how to go through the answers to this one. So statewide study shows that 22% of all people have been to a minor league baseball game this year. We take 55 people asking if they've been to a minor league game, and their response was recorded. So is it binomial? Why or why not? All right, so yes, it is binomial. And what I did was I went through and I characterized the four different criteria for the experiment to be binomial. Hopefully you did that too. Now in this example, we have that n is going to be 55. So let's start by defining the variables. N is 55. The probability of success P is 0.22, and Q is going to be equal to 0.78. And remember, Q is 1 minus 0.22, 1 minus P. Okay. So now we can go ahead and figure out what mu is. Now mu is the formula NP, which is 55 times 0.22. And if we multiply that together, 55 times 0.22 is going to be 12.1. And that's not a percentage. Okay, so remember, you do have to go through and explain what that means. And that means that out of 55 people, we would expect about 12 of them to have been to a minor league baseball game. Okay, so of the 55 randomly selected people, we expect about 12 to have attended a minor league game this year. Okay. And then for part C, we have to find the standard deviation. And remember our formula NPQ, which in this case is going to be 55 times 0.22 times 0.78. And then we just go into our calculator. We just throw that in all at once. So we could say square root of 55 times 0.22, not 0.22. And then we're going to multiply that by 0.78. And I wind up with 3.072. And then we're going to find the outliers. So let me go back real quick. So this is our 3.072. And to find our outliers, remember that's going to be where x is greater than mu plus 3 sigma. So that means that x is going to be greater than 12.1 plus 3 times 3.072. All right, so we're doing our calculator. So we're going to have 12.1 plus 3 times 3.072. Right, and that gives us 21.316. And then we can use that trick where we hit second enter. Just go back and change this to a minus. Okay. Right. So 2.84. And this is finally a problem to where both of these make sense. Right? Usually they don't make sense. So let's just copy these down real quick. So 21.316. So x is greater than 21.316 and 2.884. And x is less than 2.884. All right. And remember, to be able to get this number, x is less than 3 minus, or sorry, mu minus 3 sigma. All right, which in this case is x is less than 12.1 minus 3 times 3.072. All right, so what does that mean? Well, if we have more than 21 people or less than 3 people approximately, all right, so the outliers, and again, this is approximate, more than 21, less than 3, okay? Out of course, 55 that attend the minor league baseball. All right, so we have to make sure that what we state makes sense. All right. So for our fourth part of the problem, we want to know what's the probability that exactly 13 of the 55 have attended the minor league baseball game. All right. Hopefully you've already worked this through. Remember our formula, P of X, N combination X, P to the X, Q to the N minus X. And so P of, I believe it was 10, I just want to double check, 13, excuse me. So P of 13 is going to be equal to 55 combination 13. P, remember, was 0.22 to the 13th. Q is 0.78. And we're going to raise that to the 55 minus 13, right? And let's just go through and make sure we're okay putting that in our calculator. So in our calculator, we're going to take 55, excuse me, parenthesis 55, math combination 13. We're going to multiply that by 0.22 raised to the 13th. And then we're going to multiply that by 0.78 and raised to the 55 minus 13, which is 42. All right, so now, of course, in this calculator, you could do 55 minus 13. All right, but it's probably best if we just put it in there as 42, just so that way we can avoid the syntax errors. All right, and we certainly don't want to lose any points just because we type something in incorrectly. All right, so we get 12.1 or 0.121 as our probability. All right, so we just throw that in our calculator, and our probability is approximately 0.121 or 12.1%. So it's reasonable to expect exactly 13 of the 55 people to have attended a minor league baseball game. All right, if the probability of attending the game in the first place, all right, is 22%. Last part of the problem, 10 or 11. And just like we did before, we're going to find P of 10. And then we're going to find P of 11. And we're going to add those together. So that's 55, 10, 55, 11. P, which was 0.22. So we're going to say 0.22 raised to the 10th. And then 0.22 raised to the 11th. And then 0.78 raised to the 55 minus 10, which is 45. And then 0.78 to the 55 minus 11. And we're going to add those together. Okay, so remember an OR problem, and because these are disjoint in the same selection, you can't have 10 and have 11 people. It's either 10 or 11, right? So let's just go on our calculator, and we could use that trick where we hit second enter, and we're just going to change all the numbers. All right, so remember we're dealing with 10. 55 minus 10 is 45, and I'm going to change all the 13s to 10s. All right, so as long as you programmed it right the first time, no need to redo it again. So that's going to be 10, and that's going to be 0.108. And then let's just do it one last time. We're going to change everything to 11, which means that this is going to be 44. And we're going to change this to 11. And we're going to change the combination from 10 to 11. So a little bit faster way to do it. With your calculator, you can probably do it faster than me. Right, so that's 0.125. So we get 0.108 plus 0.125. Let me just verify that just to make sure. Yep, 0.125. And that's going to be 0.233 or 23.3%. So it is fairly likely, okay, that either 10 or 11 people out of 55 are going to attend the minor league baseball game. Right. So we're going to take a look at one last application involving the binomial distribution. And you might remember in the last type of problem, we went through and we started using combinations to be able to find probabilities to build a discrete distribution. We're going to do the exact same thing with the binomial distribution. All right, so hopefully it'll kind of give you an insight as to how some of these discrete distributions are built, similar to the example we looked at before.